All right, so today we are going to do 8.7 day 2. We're going to learn how to multiply and divide in scientific notation. So if you remember yesterday, we did all adding and subtracting. They had to have the same exponent in order to add and subtract, and then making sure it's in scientific notation. Now we're going to learn multiplying and dividing. There are definitely some things that are similar, but there are differences. So one of the biggest things that I feel like students struggle with today is knowing when do the exponents have to be the same versus not. So just be careful, and please make sure you have your notes out to help you with homework, especially since I'm not here. And your homework is going to include from 8.7 day 1 and day 2. So this is all going to be mixed together. Okay, so here's your 3 steps that you're going to do. First thing is multiply or divide the bases. So I'm going to add this like normal. So you are multiplying and dividing numbers like you normally would. Like just like if you had 7 times 6, you're doing that. If you are doing, 7 times 3, you get 21, and so on, okay? Then, number 2, you're going to multiply or divide the exponents. Okay? Use the exponent rules. So that means like when you're adding in, or when you're multiplying, you add the exponents. When you're dividing, you subtract the exponent. So if it's helpful to kind of have a little example here. So if you had x to the 6th over x to the 4th, remember you get x to the 2nd, like that's what we'll get for that. Or if we have x to the 6th times x to the 4th, remember that's x to the 10th. Like you subtract those exponents when you're dividing, and then when you add those exponents when you're multiplying. So same exact thing here. When you're multiplying or dividing the exponents, you're going to do those rules to the exponents. So bases like normal, exponents with your exponent rules. Okay? Very last thing, just like before, final answer must be written in scientific notation. Okay, and we will be very, very specific on your test or quiz on exactly like if I want it in standard form or if I want it in scientific notation, okay? So we're gonna do a couple examples of both. So example 1, these are multiplying things in scientific notation. Example 2 is dividing, okay? So very first step, we're just gonna multiply or divide the bases like normal. So here's my bases, 5 and 3. I do that like I normally would, so 5 times 3, that would give me 15. So I'm gonna first write 15. Okay, that timesing by 10 doesn't change. As like yesterday, that timesing by 10, that's always going to be in scientific notation, so we don't really do anything with that. Then when we are multiplying, we are going to add these exponents. So just like in your multiplying, remember like the bases, I know the bases technically aren't the same in this case, but we're kind of treating the bases with that times 10, so they are the same. So these ones, we are going to add these exponents, okay? When we add those exponents, we get -7. -5 plus -2 gives me a -7. Okay, and then the very last thing, final answer must be written in scientific notation. Okay, so right now I have too big of number, 15. That base is not between the 1 and 9.9, so I have to make my 15 smaller. Remember what we did is we had to make an exponent, so I take that 15, I put an exponent on the bottom, on the way on the right, and then we're gonna move it to the left 1 time. Okay, that is going to make my base smaller. So when I make my base smaller, I make my exponent larger. So if I made this smaller, so 15 to 1.5, that's a smaller number times 10, I have to make this larger. So be careful, it's negative. So -7, 1 larger would be a -6. Okay, so that would be my final answer, 1.5 times 10 to the -6. Okay, second one, if we're multiplying, we got to multiply and divide the bases, so we just take that 7 times 3, do exactly the way we normally would to give me 21. So that's 21 times 10. And then multiplying things, we've add those bases. So we are adding the exponents of 2 plus 5, and that gives me 7. Okay? It's not in scientific notation. 21 is too large, so we have to make it smaller. So I have to make my decimal point at the very end, since there's not a decimal point, and we're going to move it 1 place to the left. So that means I've got 2.1 times 10. If I made my base smaller, I have to make my exponent larger. So like if I'm moving a decimal place, that's adding or subtracting an exponent like we learned. So that means this is getting smaller, so that means this gets larger by 1, which gives me 8. Okay, same steps for dividing. So multiply or divide the bases, then we're gonna do the exponent rules, and then our final answer should still be written in scientific notation, okay? So we've got 1.5 and 6. It is being divided. So I'm going to divide like I normally would. So dividing those two numbers, if you put it in your calculator, I know some of you are great with decimals. I would actually even say I'm not great with decimals too. So 1.5 divided by 6, that would give me 0.25 or 0.25. And then I still have times 10. And then for my exponent, when I am dividing my exponents, my exponent rule, remember, that means I subtract the exponent. So I'm going to take -8 minus 7. Be careful with this. -8 minus 7. It is going to get a bigger negative. If I had -8 minus 7, it's almost like saying -8 and -7. If I put those together, I get a -15. Okay, maybe put those straight in your calculator to help you. I think negatives are the thing that I get people mixed up the most with this, is if people that have those negatives or forget the negatives, or I get a lot of -1s in this case. Remember, you are subtracting. Okay, final thing I got to do is make sure it's in scientific notation. So if we have 0.25, that is too small of a number, so I need to make that larger. It's not between 1 and 9.9, so I'm going to take my decimal place wherever it is, and I'm going to make it 1 larger to get that 2.5. So that means I have 2.5 times 10. If I made my base larger, I have to make my exponent smaller. So if this was -15, and be careful again, it's negatives, what would make it? I need to make it 1 smaller, which would be a -16. Because obviously if you add another negative to it, that's getting smaller. Okay, it's always like the opposite of that. B, divide those numbers. So 3.75 divided by 1.25 is going to give you 3. And then we've got times 10. And then subtract these exponents. Really be careful with this. This is what I was telling you about with exponent rules, that sometimes that's why I moved it. This is one common mistake. I have 3, and I subtract my bottom exponent, which is a -7. Okay? Negative and a subtraction sign turns into a big plus to get me 10. So that means I got this to the 10th power. Okay? Last step, final answer must be written in scientific notation. My base is between 1 and 9, so I actually don't have to do anything else to it, and it already is, which is so nice. Okay, last example. So how many times greater is the diameter of the sun than the diameter of the earth? So this would be a great example that I will actually make sure to tell you, do I want it in standard form or do I want it in scientific notation? In this case, let's just keep practicing that scientific notation, and I think most of your homework problems are going to be like this anyway, to make sure that you leave that in terms of the scientific notation in that way. Okay? So if I want it in scientific notation, I want both of these in scientific notation. I want to know how many times greater something is, so I'm going to be dividing. If I want this in scientific notation, I'm going to first find my decimal place. If I don't have one, it's at the very end. Okay? I got to count as many as I get to my base between 1 and 9.9. So I go 1, 2, 3, 4, 5, 6, and there is my decimal point. So that means I got 1.4 times 10, and then it's to the +6. And what's nice about 8.6 is we learned both ways. Like, you can get it in scientific notation and we can get it back in standard form. It's actually a great way to check your work to make sure you're doing it right. If I did this in scientific notation and you're like doubting yourself, like you're like, wait, is it negative or positive? Go the opposite way and make sure that's it. Okay? So how many times greater is the diameter of the sun? So here's the diameter of the sun, then this one. So if I want to know how many times greater something is, it's almost like what times this gives me this. So that means I need to divide those numbers. So that means I take 1.4 times 10 to the 6th, and I'm dividing 1.28 times 10 to the 4th. Okay, when I divide those numbers, we're doing the same exact 3 steps that we do. We first are going to divide our bases. So 1.4 divided by 1.28. It is going to give me a pretty long decimal. Now, unless I tell you to simplify or round to the nearest 10th place or anything like that, you are giving exactly what they give you. So in this case, I have 1.09375 is what I get, and that is exactly what I want you to leave it as, because it wants to divide those numbers the exact way it is. Okay, then I've got times 10. And then when I'm dividing things, I subtract the exponents. So I have 6 and 4. So I'm going to take 6 minus 4 to give me 2. Okay, final step, make sure it's in scientific notation. I have my base between 1 and 9.9. It's times 10 to the square. Okay, for your homework today, you are going to have big ideas. And I think I said this in the beginning already. Just make sure that you know Big Ideas is actually going to be from both things. So it's going to be both from 8.7 day 1 and 8.7 day 2. So please make sure that you review that. So I have some adding and subtracting. So look at the operation you're doing first. So remember, adding and subtracting is from day 1, multiplying, dividing is from today. I also am going to put some notes on the board for you to help, because I know there's going to be some review from that. There also might be some that you have to do PEMDAS, like what order you do it in. You would do the same way and then do something like this. Okay? Good luck.